Hi everyone, so this is the Edwards Vacuum Career Talk from myself, Jasmine, and my colleagues Charlie and John. So we all do different types of engineering, electronic, mechanical and software. So we're each going to be telling you a little bit about our discipline in engineering and what we do at work. Also, we're going to go into detail about what career path that we took in order to get to our jobs. And finally, we'll be telling you about what a degree apprenticeship is and what the benefits and challenges can be. So my name's Jasmine. I'm an electronic and also an electrical engineer, and I'm a degree apprentice at Chichester University, and I'm currently in my second year. So before I get into it, I just want to introduce myself and tell you a little bit about myself. So I'm from a place called Medway, which is just southeast of London. It's where I was raised and I miss it a lot. I only just recently moved from there to come to Eastbourne to work for Edwards. And in my free time, I like to play video games online with my friends and also fix things that my friends and family break. So what is my job? What actually is electronic engineering? I definitely hadn't heard about this until I went to college when I was 16, so you might just be wondering what exactly is electronic engineering. So basically, you deal with electronic components which are inside your devices. So an example of some electronic devices would be your phone or your laptop, even like your oven, things like that. Basically, almost anything that uses electricity will have some kind of electronic components inside it. So an electronic engineer's job is to basically design and also potentially fix these circuits inside your devices in order to make them work in the way that we want to. So what do you need to be good at or potentially interested in order to potentially be an electronic engineer? So in terms of school subjects, it's pretty straightforward. We've got some examples here are physics, maths, computer science or IT, and also DT or design and technology. So anything that's got like a design element or mathematical and theoretical elements. If you're interested in these, then electronic engineering might be the right career for you. So now we're going to have a look at some qualities that would be desirable if you wanted to be an electronic engineer. So solving problems is really important. That's literally what my job is to just solve problems all day. And that's also that also is included in the design process. It's not just if you're fixing products, but when you're designing products, there's often going to be different barriers in the way and different things that you can't solve or that you need to solve. So again, having a good tendency to solve problems is very useful. Being detailed and meticulous is very useful as well because you're working with very tiny components most of the time and also very kind of slight differences between measurements. So being clued up when it comes to detail is very useful as well. Being organized and having good time management. I mean, in any job this is useful, but specifically in engineering, there's not enough engineers in the UK, so that means is that most teams are understaffed, which means you're going to be working on several different projects at once. Again, I don't want to scare you away from the job, it's not too bad, but all it just means is that you kind of need to be quite good at managing those projects separately and also managing your time so that you're not neglecting one of them or more of them. And so you're kind of balancing those different projects. Good communication skills is really important. This surprised me because when I was going into engineering, I didn't really think that communication would be that important. But actually, from having been in the job for a year now, I just spend all my time talking to people. You really do just have to talk to lots of different people, not just within your department, but also in other departments as well, with your boss, with your teammates and your colleagues, especially if you're working in a team project as well. So having good communication skills is really important as well. And then finally, obviously, having an interest in technology and electronics is desired. When it comes down to it, when you take apart a car or a phone or even something obscure like a vacuum pump, which is what we make here at Edwards, beneath the surface, they're all the same. All the electronic components that they contain do the same thing. So whether you're interested in cars, that doesn't mean that you can't work on something else. but obviously having that interest is quite key. I'd just like to add on at the end that obviously all of these are desired qualities, but don't be off-put if you feel like you haven't got all of these or haven't got any of them. Actually, if you work for the right company, which I think, you know, Edwards is really good at this, there's a really kind of growth atmosphere in the company, which basically just means that everyone's really supportive of you. You know, my manager's very supportive of me and my growth in my role. So when I came to my interview, I didn't have all of these, you know, but they kind of saw that my passion was there. And the desire to learn and be good at all of these things was there. So even though I didn't have them, they could see that I had the potential to have them. So don't be off put if you feel like you don't have these, because at the end of the day, as long as you're kind of committed and motivated to learn these, then that's what's going to make you a good engineer. Okay, so I'm going to go into a bit of detail about what I actually do at work, and I'm going to do that with a case study to show you a project that I've been working on for the past sort of 6 months. So this photograph is the Gen 4 dashboard, and it has a number of different components on it. It has resistors, capacitors, inductors, buttons and LEDs, which you can see on the front there, and also an earth point. So this is a product that we make at Eastbourne, and what that means is that we have to test it before we ship it out to any customers. Now, the current test system that tests the dashboard is breaking and it's old, which means that it's failing dashboards that are actually completely fine. So the project that I was put on, me and my colleague Joe, we are working to build a new test system for the dashboard. So there's quite a lot that goes into making a test system, but I'm going to try and break it down for you today. So we're going to have a look at some of the key instruments that are used in the test system. So if we start from the left, we've got a digital multimeter, or a DMM for short. You might have worked with one of these before in a different form. Basically what this does is measures different electrical qualities. So for example, that could be voltage, that could be current, it could be resistance or capacitance or continuity. There's loads that you can measure with this. You might have used like a voltmeter or an ammeter to measure current before. This is basically a voltmeter and an ammeter all in one with lots of other things. So the reason that we need this in our test system is that I described the components that we have in the dashboard earlier, but what we need to do is make sure that all of these components are the right value, because if we don't have the right value of resistor or capacitor, it could cause the dashboard to not work properly when it's on the pump and when it's with the customer. So we need to make sure that they are of the right values, and that's what the DMM is for. Secondly, if we have a look at the matrix switcher, this is quite a complex instrument, but it's really very simple when you break it down. What the matrix switcher does is it helps to control lots of different relays at once. If you don't know what a relay is, it's basically just a switch. You may have seen a switch in like a schematic diagram before. It just opens and closes in order to make a closed circuit or to stop the circuit from being complete. So that's what a relay does. It opens and closes a circuit, or a switch rather. It opens and closes. And what a matrix switcher does is allows you to control 64 or even more or less relays all at once from one machine. Now lastly, we have our power supply unit, or a PSU for short. This does exactly what it sounds like. It provides power to a circuit. So we have one that has 2 PSUs on it. So the first one is needed because our LEDs require power to go to it so that we can measure the current. Because if the current is too low, then what that means is that the LED might break prematurely, so it's not used to the kind of the full extent of the life of the dashboard. And the second PSU is used for the matrix switcher because the relays actually need to be powered in order to work. They work a little bit differently to normal switches, but basically they need a little bit of power. So that's what our PSU is used for. Okay, so finally, we're going to have a look at how all of these instruments connect up together to make our test system. This here is the hardware of our test system. So firstly, you can see that the pins from the dashboard connect to this line of terminal blocks. So obviously we're testing the dashboard, so we need to make some sort of connection between the dashboard and the test system. So this is where the wires come from the dashboard into this line of terminal blocks. Secondly, we have the other two sets of terminal blocks, which is where our DMM or our digital multimeter and the PSU or the power supply unit connect up as well. So we're bringing everything together so that it can all be accessed in the same place. Thirdly, we have the matrix switcher. So this is where the matrix switcher connections are, and you can see that they're going out to the relays, which is the last bit of the test system. And the relays, as I explained before, they're kind of like switches. So the matrix switcher connects up to the relays so that they can control, so that we can control how they open and close. So there's quite a lot here. I hope that you've kind of understood, what's going on here and how it all connects up. Basically, we will then use this to operate everything from a software program so that all the testing is done automatically and the user will just have to sit at the test program and basically everything will be done for them apart from visual checks. I'd also like to mention that we did actually design the software program for this as well. So even though we're electronic engineers, there's actually a little bit of software engineering that goes on as well. So now I'm going to pass over to Jonathan.
Hi, my name is Jonathan. I'm a degree apprentice at Edwards studying manufacturing engineering. A little about me. As you can probably tell by the photos, I grew up with a passion for mechanics. Did my A-levels in maths, physics and computing. Most of my hobbies are quite outdoorsy. If it has moving parts or wheels, I'm probably interested in working with it. So, what's my job? I'm working in a section called NPI, which stands for New Product Introduction. It's an engineering role that deals with developing and bringing new items to the market. The picture at the top is a layout I produced recently for a new production zone within our factory. The picture below is a typical example of an electronics production line. In this role, you get to learn about lean manufacturing principles and techniques. Soft skills and organisation are essential for this role, as it involves communicating with lots of people, both in and out of the company on an almost daily basis. There is no real typical workday for me, as working in NPI has so many different elements needed for releasing a new product to market. I would recommend maths and physics as the core subjects for this role.
Hi, so I'm Charlie Harrison and I'm a software engineering degree apprentice at Edwards Vacuums. I'm from West Sussex. I used to be an air cadet and I managed to get to the rank of flight sergeant. Had a lot of fun there, but I unfortunately aged out, so I'm no longer there. I also have a hobby of 3D printing, rock climbing and clay pigeon shooting. So what's it like as a degree apprentice? So 3 to 4 days a week, what I do is I do, unsurprisingly, software. So examples that you might be familiar with would be programming, debugging and designing bits of code. At the moment I'm currently testing a lot of APIs that the company have been making, and some examples that you might be more familiar with are things like websites, games or physics simulations. You might have some of those at school. And some of the traits and skills that you might want if you wanted to pursue a path like this yourself would be definitely persistence. Your code's going to go wrong a lot more times than it's going to go right. You're going to need to be patient. Again, there's a lot of time waiting around for computers. It's going to be a fact of life that computers are slow. And a bit of personality never goes amiss, especially in the software department. So the other 1 to 2 days a week will be lectures at university. Unsurprisingly, there's programming in there, so you'll be learning a variety of different languages and different purposes for the different languages that you use. Slightly more surprisingly though, you'll be learning about soft skills and you'll get an appreciation for what you need in the workplace. So things like your personal development planning and your ability to manage yourself, your time, organise, and you really start to understand how important that is when you work in that environment. And slightly more interestingly, again, we've got hardware and networks. So if you've been interested in what's inside a computer or how they talk to each other, you'll get the opportunity to actually handle the components and put them in a machine if you take this particular course. I found it particularly interesting myself. Another little side note to add is that sometimes when you stay overnight, your expenses and your accommodation are paid for. Won't sound particularly exciting, but that will really start to add up by the end of the month, and you'll be really grateful when that does come through. You'll notice this particularly with engineering companies, anything in STEM really. It's really quite helpful to have, and I'll definitely recommend it.
So we've all gone through our jobs and kind of our different disciplines of engineering, and we're now going to go through our career path so far of how we got to our job at Edwards. So my career path was actually pretty straightforward. I came from secondary school where I went to in Medway, as I said, that's where I'm from. And I decided when I was in year 10 or year 11 that I wanted to not just do A-levels and not just do a BTEC, because I thought A-levels were a bit too academic for me. I didn't want the stress of having to do 3 A-levels. But also I didn't just want to do a BTEC because I thought that, I thought I was capable of more. And luckily, there was a UTC right in Medway that I could go to. If you don't know what a UTC is, it stands for University Technical College. Basically, it's a type of sort of secondary school / sixth form college, and it's basically geared towards people who know that they want to go into engineering, construction, or design. So it's just, it's just kind of more specialized. And the reason why I went there was because they allowed me to do both a BTEC and A-levels. So I did my BTEC in engineering and my A-levels in maths and art. That went really well. I was really pleased with the grades that I got. And I was determined that I was going to do a degree apprenticeship once I was finished. So I applied to lots of different places and finally settled on Edwards, who accepted me. And so, yeah, I just went straight from college to Edwards, and I'm currently doing my degree at the University of Chichester. So this is just my final little bit from me today, and it's just to give you a little bit of advice. I think it's really important when you're younger to spend a little bit of time just nurturing your interests and finding out, just exploring what it is that you want to do when you're older. Obviously, it's not the end of the world if you end up with the wrong thing, but I think it is just more enjoyable if you know that the thing that you're studying at university or the thing that you're working towards is the right thing for you. It will just make your life easier. So there's a few different ways that you can nurture your interests. You can do work experience, which was super valuable for me when I was young. I didn't really know what engineering was until I did work experience, and it was only until I did work experience that I thought, yeah, this is what I want to do for a job. The thing is that work is really different from school. Like the working environment is very different, and I think if you never see that, it could really alter how you view the career that you want to go into. So I'd say for sure try and get some work experience in whatever sector you're interested in, just to see it, just to really see if that's what you think you want to be doing. You can work on little projects at home. So for example, if you're into software, why not do some coding at home? Why not code a little game for yourself or something like that, And it doesn't have to be a lot of time. It can just be like an hour a month that you put into it, or an hour every 2 weeks that you just come back to it and have a look at it. And again, it's just to kind of see if that's really what you want to spend, 9 to 5 doing. Do a little bit of research maybe, especially if you're in coming towards the end of your school years. You might want to research what university courses are available to you, what apprenticeships or degree apprenticeships are available like in your local area or even in the country. Just putting in, like an hour of research a week could be really beneficial, and you may even come across something that you wouldn't have thought about before that could open up opportunities to you. And then finally, if there's clubs or like extracurricular activities that are provided for you, and especially if they're free and you're interested in them, I'd say why not do it? Do you know what I mean? It might feel like a lot of time that you're devoting to it, but I promise that, as you know, it's a good way to invest your time just to make sure that it is really what you want to go into for your career.
So I think out of the three of us presenting today, I've probably got the rockiest career path, you could say. Not the typical route you'd expect someone to take. So did my GCSEs, got my A-levels, did a foundation year at university in mechanical engineering, while working part-time as an auditor. After that, I decided that full-time education wasn't the best balance for me, and I wanted to work more. So I moved back home, drove miniature steam trains for about a year, and then joined Edwards as a production line worker for a couple of years. It was only 2019 that I started my apprenticeship. So my advice to you, be hands-on, get experience where you can. Free time at your age for exploring career prospects is a lot easier to come by when you're young. If you don't ask, you don't get. There are lots of resources about, even asking local companies for information or volunteering work. It can go a long way for your future. There is no set career path, no matter what people tell you. Just look at my career path. Soft skills and working effectively in teams are, in my opinion, just as important as qualifications. So definitely don't overlook them when considering your line of work.
So my path so far, I did my GCSEs at St Andrews. It's an all-boys school in Worthing. I didn't do exceptionally well at them, but I did all right. Got 11 GCSEs, and then I went to do my A-levels at Collier's. I've got a little asterisk there because the first time I went, I did drop out. I took 2 years before I even came back to beginning my A-levels again. The second time round I did do, and I did finish them and pass. And then that led on to work. So just under all of that, I've got the air cadets I've put there. The air cadets, through there, I met a staff member that put me in touch with someone at Edwards, which was how I found out about the company. And also I've put it there because I think there's some important skills that I learned while I was in the air cadets. You probably hear this a lot, but you really begin to appreciate the significance behind these qualities when you actually have to use them and demonstrate them in an environment. So through the air cadets, I've got qualifications in leadership. I've got qualifications in lowland walking and outdoor activities, and a lot of soft skills. So generally managing yourself and organising your time. It all becomes really important when you start to get into the workplace, and you find that there's a lot more to it than just working hard. You realise you have to manage yourself a lot and work in a team and work with others. So at the Eastbourne Product Company, we have what's known as the career ladder. You can see on here we've got people moving from different stages in their career to the next. Theoretically, and not just theoretically, practically, it is possible to go from coming in as an agency worker and leaving as the general manager. It's been known to happen, and it's been known for people to go further than that. The moves don't just have to be up, they can be sideways as well if you want to transition from one role to another in a different department. And that sort of flexibility is really, really helpful if you find you have a change of priorities. It's not necessarily part of the apprenticeship, but working for a company like this, you do realise there's a lot more opportunities than just being stuck in the same career path. And then on top of that, Edwards is part of a larger decentralised group known as Atlas Copco, and within there they encourage you to move between companies, diversify your skills. You can see here there's loads of companies you can move between. Some of them even used to be our competitors, and in fact the current president of the scientific vacuum technique used to go for, work at one of our competitors at Leibold. You can see them at the bottom there. And on top of that, there's the opportunity to potentially travel once you graduate on the graduate scheme. You can see in this picture here, here's just some of Atlas Copco's headquarters, production sites, and countries covered by the Atlas Copco service centres. Although, yeah, you're not going to travel to all of them, there may be the opportunity to travel if you're up for it, and that's something else that you can consider. So my advice to you in the meantime would be to enjoy your GCSEs. I'm sure you've got a lot of people telling you to relax and take them easy. Of course, take them seriously, but don't feel too pressured to perform or overperform. The grades that you get now won't define what you'll potentially be doing in 5-10 years time. Make sure you engage with your professionals. They may be your football coach, they may be a staff member at your cadet group or a scout leader. You never know when that might come in handy or what door that might open for you, and remember to always stay in touch with those people and don't feel like you have to rush. I fell off the horse, I dropped out of my A levels, and you realise actually you can, if you're willing to, you can always get back on it, and it's not the end. There's always time to pick it up and come back to it. So here's how I'd summarise degree apprenticeships. You'll do 3 to 4 days at work. For every 1 to 2 days you do at university, it should be about 20% of your time learning, at least. Sometimes you'll do that daily, sometimes you do that weekly. And this is what my work week looks like. Mondays, Wednesdays, Thursdays and Fridays are at work. Tuesdays are at uni, and of course the weekend. So the pros to doing it this route would be that you've got your salary and you've got no debt. The university course is entirely paid for. You've got professional development. You're surrounded by a lot of people. You've got your mentors. You've got the professional colleagues you work with. You realise exactly how much talent there is, and you're spending a lot of time one-to-one with people even when you don't realise it, and you're learning a lot. There's a lot of applied skills, so things you learn in class aren't just completely abstract and non-real. You actually get to use them in real products that you produce. And particularly with our company, we get healthcare and expenses, which is very helpful. I get my glasses paid for and my dental. Some of the cons is that it can be challenging. Sometimes you're given a project where you really feel out of your depth, but of course with the help of others, it's never actually too much, not too daunting. It can feel a little bit time consuming, so you've got of course your university assignments and intersessional work you have to handle alongside a 9-to-5 job, which isn't always too difficult if you're organised and you develop those soft skills and you stay in contact with your managers. They're always happy to lend you a hand and give you some time to work on it yourself. And applying, this is a completely different application process to your standard UCAS application. It's not necessarily so grade focused. You do have to be able to provide that experience, and your out of school and extracurricular activities that you've taken part in really help to going a long way to making you a standout candidate. And responsibility, so you're responsible for what you produce. It goes on to affect other people, unlike what you might do at university, where it's solely affecting yourself, your own grade and your own understanding of a subject. When you're at work, you need to make sure that what you're producing is fit for the next person in the supply chain. So here's some misconceptions. Some people believe the degree isn't the same. This is in fact the same course that any other university student would do for their software engineering degree. In fact, we just do it over 4 years instead of 3 to accommodate for the extra time. Apprentices are just cheap labour, so we don't just do menial tasks, we actually own real projects. Like I said, I'm currently working on testing some API calls. Another colleague of mine is actually working on an entire project himself. And another misconception is you just make tea. If anyone actually knows an engineer, all of them seem to be really quite picky about how their tea's made, and if you offer, they'll just tell you straight up, no, you won't make it right. So it's a really complete different experience to what you might have in your mind about what an apprenticeship is like, especially when you get to the degree level. So if this hasn't sold you by now, I'd like to just introduce one more fact. So if you look at what the net gain a student might get against an apprentice over the 5 years of their education and work, this might just summarise it for you. So the student's accruing at least £9,000 of debt a year just on the university course, not including their accommodation, whereas the average apprentice wage that I've found comes to £18,000 a year. So in the first year, you'll see there's a big difference there, and not only that, an apprentice's wages often go up. I've used the average figure here of about £500. Many places do more than that, some places do less. And we just take the average as we go along, and by the third year, the apprentice, their net gain would have been £55,000 on average, whereas a student would have at least spent £20,000 on their course. Of course, the university graduate is likely to graduate 1 year sooner than the apprentice, but when you realise that by the time the apprentice graduates, they will have 4 years experience within the company they work in, and that also contributes to them potentially having a higher pay by the end of their course. So you'll see that there's a wage gap there at the end as well. I've used these averages that I found on the student room, and these should be very reflective of the market at the moment. But don't take these as a literal value.
So thanks for listening, guys. I really hope that this was useful for you to kind of get an insight into what different kinds of engineering are like and what we do at our jobs, and also a bit about degree apprenticeships. I think they're a really good opportunity. And if you're right for it, then I'd say, why not go for one? If you have any questions, please go ahead and ask, or you can email the STEM Hub, or ask your teacher to email the STEM Hub, who will hopefully forward the questions to us and we can get back to you with some answers. Thank you very much.